So I guess we'll go ahead and get kicked off here, starting now. So I want to welcome everyone to tonight's event on big data from complexity to simplicity. My name is Ryan Joy. I'm based here in Austin, Texas as a startup evangelist with Microsoft. And we also have Sam Cozannet from Barcelona, from Canonical, who will be talking about their product, Juju. And so a little bit about what I do. This is my chance to essentially give you the spiel about how we work with startups. And so with that, how many of you all have heard of Microsoft Bizspark? Awesome. So Bizspark is our offer for startups, and
Microsoft Bizspark is
video.
Cloud services, software, and tools tailor-made for startups. Joining is free, and members have 3 years of access to Microsoft's Azure cloud services, up to $750 worth of credits per month for new startups for all your developers.
That's up to $27,000 in value over the life of your membership.
Azure works with the coding tools you know, including Linux, Java, PHP, and a gallery of open source tools.
Create a virtual machine.
Deploy a website or web app. Store your data and video and deploy a mobile app, all in your first month.
Tap into an additional $120,000 of Azure credits through the Bizspark Plus program.
With this much Azure cloud, you can take advantage of powerful platform services such as machine learning, media services, and hub notification. Build and scale faster and connect with more customers. And when you're ready to connect, we know a few people who might like to meet you. So if your startup is less than 5 years old, privately held, and has less than $1 million in annual revenue, we invite you to join the Bizspark program. It's simple. Build how you want to build, and then build up. Join Bizspark today.
yeah, so as that video mentioned, the Microsoft Bizspark program essentially gives you access to an MSDN subscription, which gives you all the software that Microsoft makes, especially for developers. So SQL Server licenses, OS licenses, Visual Studio Ultimate licenses, as well as $150 per month per developer for your startup in free cloud. And if you qualify, if you're actually consuming a lot of cloud and really on that rapid growth ramp, then there's also an offer of $120,000 in Azure Cloud for you as well. For any of that stuff, you can come talk to me, come to an accelerator or partners such as Capital Factory here in Austin, and we can talk more about that. And that's especially important as after Sam's talk today, you want to go out and play with Juju and play with some of these tools. And this is some of those offers that help you really start to get your feet wet and start to utilize some of these awesome technologies. Some other things I wanted to specifically talk about are a little bit about an overview of some of the open source initiatives with Azure. So, these past few years, Microsoft has made a huge commitment to open source. Microsoft has always been a contributor to open source. Even on the Linux platform, you'll find that Microsoft has always been working to make sure the services and the bindings or whatever needs to work works with our products. But with Azure and exposing those open source products as services and features, we've really doubled down on that. In fact, just in the past year, we announced that we have 20% of our Azure VMs are Linux machines, Linux images. HG Insight is running on Linux as well in the Azure cloud. We open sourced the core CLR for .NET. Open source ASP.NET and OWIN. Released the Azure Redis Cache, which is our default cache solution for cache as a service within Azure. We deployed Azure Search, which is actually built atop of Elasticsearch. I've been working very closely with Docker. In fact, been also working on Windows containerization technology across the board with a number of different partners. In fact, and constantly work with over 150 plus standardization bodies. And any number of additional things. So just a few of the open source on Azure partners that we have available to deploy, obviously Ubuntu solutions such as WordPress or CouchDB for database, many app frameworks, many data solutions, tons of different things. And then one additional thing we have this service called VM Depot, which is a community-driven space where you can find images for many solutions. And in fact, after the talk today, I definitely encourage you to go out, find the Juju image, and deploy. And I think Sam will talk a little bit more about exactly how easy that is to deploy a Juju instance or Juju cluster onto your Azure cloud. So to sum up, Microsoft Azure is an open cloud, is your open cloud. We have the needs for integration and including on-premises and within the Azure cloud all met. And we believe that we need to be heterogeneous in this cross-platform, cross-cloud, multi-OS, polyglot language world that we live in today. And with that, specifically because I have a few more minutes to speak, I wanted to bring up one additional person from Ubuntu if you wanted to chat a little bit about containerization and some of the exciting stuff that's happening there. This is Dustin Kirkland.
Thanks. Yeah, my name's Dustin. I work at Canonical. I'm a product manager based here in Austin. One of the products that I look after in Canonical is called Linux containers, LXC, and then the manager, the daemon that can help control and manage those containers, something we call LXD. These are both open source projects. We've been contributing to Linux containers and maintain Linux containers at Canonical for about 5 years now. LXD is something that we've built over the last 9 months or so. LXD really treats containers like virtual machines. LXD is a hypervisor, so to speak. So similar to the way that a hypervisor, a KVM or a Zen or a Hyper-V, is a thin shim at the bottom of a physical system that can then provision those physical resources, CPU, memory, and network, and disk, to virtual machines. LXD does that exactly for containers. It takes a running operating system, rather than running below the OS at ring 0, it actually runs in the OS as a daemon itself. That's the D part of LXD. But it makes available the resources that are in that system, CPU, memory, disk, network, etc., and can chop those up into containers. Just this morning, actually, we announced an initiative called fan networking, which is a really interesting way of making any two containers within the same cloud addressable directly to one another. That's one of the biggest challenges we're seeing now in containers, is containers scale out, right? It's totally possible. I've run over 600 containers on my ThinkPad, and the system was still usable and functional. When you start running hundreds or even thousands of containers on servers, they need some way of talking to one another. There's the current state of the art is to use something like software-defined networking, or any one of a number of other distributed databases that track what container is where. We released something called the fan. If you look up Ubuntu and fan networking, you'll see a really interesting solution. It's IP tunneling, and it's deterministic routes, basically. So if you want to hear more about that, I understand there's a question and answer at the end, and I'm happy to talk a little more about that. Yeah,
absolutely. I mean, containerization, if you haven't noticed, is just changing the way that we do software deployments and DevOps all up. And I think there's a lot of exciting work that's coming out of the partnerships with folks like Ubuntu and Canonical. Cool. So with that, I would like to welcome up Samuel Cozannet. Again, welcome to Austin, all the way from Barcelona. He's going to walk us through Juju. While he's getting set up, if everyone wants to, if you want to grab another coffee or beer or more charcuterie, go for that.
You awake? There we go. Nope. No, that's me. You guys, maybe HD mic too.
Yeah, so HDMI is on.
It's not good.
Maybe one moment long while we grab the Capital Factory AV expert.
There it is. Ah, it's good.
Okay.
Okay. Hi everyone. Just wait for people grabbing stuff. Okay, so my name is Samuel. I work at Canonical in the strategy team, and I focus on a product called Juju. So Juju is a cloud orchestration solution that I'm going to present to you, and also introduce you at how Juju works really well with Azure, and how you can test it today, tomorrow, and play with it over time. So Canonical is a company behind Ubuntu. So if you don't know about Ubuntu, it's the leading open source operating system. We've been around for 10 years now, and we have more than 600 people located in more than 30 countries, 6 main offices, and with about 100 people working down there, and the rest work from home, like me. Besides Ubuntu, we also work on professional services, so we do consulting to deploy, run OpenStack on your behalf. We do support for Ubuntu at scale. And we also have a range of products around cloud orchestration based on 3 products. Landscape, which is something to manage a lot of Ubuntu systems at scale. Mass, which is enablement of bare metal servers. And Juju, that allows you to build complex architectures and run them on Mass or any public and private cloud. The history of Juju goes back about, let's say, 20 years ago, when architectures or enterprises were counting the number of systems they were using by the unit. They grew after that, and they grew, bought more servers, and got to hundreds of units. And then they started virtualizing, and got to thousands or tens of thousands of units. And now they're adding clouds, so it's basically a continuum. They got millions of units running. The issue with this is that the tooling that's been built to address IT was basically born when we used hundreds of devices. So that means that we thought it would be possible for a team of admin to be omniscient about everything that would happen in an infrastructure. The other thing is that we thought that repeatability would only incur inside a given infrastructure. So if you wanted to run the same thing somewhere else, like another cloud, the same tooling was not considered. So that's the history of configuration management. Being able to design every single aspect of one machine, being able to maintain it over time for a very long period of time, and all that provided that the environment in which that machine was running was known in advance. But that fails if your infrastructure or the services you're running are too big to be managed by a single person or a single group of admins. So you need something more. And our answer to that has been to rethink how an architecture and a service and application was built. So we've designed two things. One, the first thing is called a charm. And a charm is an expression of how to deploy a unit of service and a service, how to scale it, and how to integrate it with other services. And the second thing is a bundle. And a bundle is a set of services that are integrated together, regardless of the scale of each service. So that's it. It's looking at a set of many, many units running software and abstracting that in a service view. And then all the services relating them together, regardless of the number of units. What we're asking for from charms and bundle are four main properties. Reliability. When you design a charm and you want that to deploy and do exactly what it's supposed to do, as in how it's documented. You want that deployment to be repeatable. So if I run 1,000 units or tens of thousands of units, I want them all to work. I want that to be observable, which means that the output and what I can see from the environment and from those machines actually represent what's happening inside them. If one fails, I want to know how and when and where. And you want that to be fast. Faster actually than how you would manage it yourself or with configuration management. On top of those four properties, we've got three more that we add. The first one is portability. Services shouldn't be tied to a specific cloud or deployment surface. That means that we want to address public clouds, private clouds, bare metal servers, containers, anything that can run an application. But also you don't want to be tied to a single OS. So we want charms to run on Ubuntu, on CentOS, on Windows, on any OS that you can think about. The second one is the scale. I mentioned that bundles, which are those big applications, are designed regardless of the scale of services. So we have a notion of scale that is built in Juju and built in that language. And that scale out, obviously, but also scale in if you don't need more of those resources. And the last notion, and maybe the most unclear so far, is open source. We want those charms, which are expressions of how to deploy your application and how to scale and integrate it, to be open source. Because we want them to be the best breed of how to use each single service. So we want the community to be able to help you and create better charms all the time. So what we did was first build a language. And that language has only 3 words: service, relation, unit. Service, I already talked about it. It's something that can be consumed by a human being, a machine, or another service. A unit is an atomic unit of service. So one service starts with only 1 unit, but you can scale that out. And a relation is how two services should talk together, what they should expose, and how they should consume what's exposed by others. Now, a language is only useful if it's spoken. So on top of that language, we've built a cloud orchestration framework, and that's actually what Juju is. It's something that will understand the language of charms and bundles and allow you to put it in action and in motion in the real world. So Juju understands that it can deploy a bundle, and it can talk to any public cloud, any private cloud, bare metal, containers, name it. What did we do with that? Over the last 5 years, our initial focus was to work with OpenStack. So we've become very, very successful at that. We've got a set of charms and bundles to deploy OpenStack in many different ways, using different VNF solutions. So we can build private clouds, and that's today one of our profitable activity. We are leading with the OS. So Ubuntu is present in 55% of private cloud deployments. And we're also really good on the global market share using Juju. Over the last 5 years, we've also worked with every single public cloud to be able to integrate Juju with them. So we've got a notion of provider, and we can deploy on Azure, Amazon, SoftLayer, Google Cloud, giant orders. And for the last 18 to 24 months, we have also started to create a community of users around Juju so they can charm the application. So we teach them how to make sure that they can run and they can adapt their workloads and deployers to Juju. So far, we've got 1,600 charms, and 250 of them, a little more than that actually, are recommended. Recommended is a notion that it has a support from the company, and also that it's been reviewed by our charmers team so that it's validated that it works on all the clouds and all the deployment surface we have. Altogether, that's about 500,000 deployments, regardless of the number of units that have been deployed. So it's 500,000 of different services that have been deployed through Juju over the last 5 years. Now, this is also a talk about Azure and Microsoft. So all clouds are not equal with Juju, and Microsoft Azure has some specifics that make it really useful for us. The first one is the fact that from an instance you deploy in Azure, you can access user credentials through the Azure settings file. So that allows you to know about your environment and to actually integrate with the environment much faster. So to us, it allows us to create a Juju image that can spin on Azure natively and be automatically integrated with your environment, so you can pin more units and more services and more bundles with Juju. The other thing is a commitment that Microsoft is doing to Canonical and Ubuntu in general to integrate Azure services from Juju environments. So I mentioned that you can deploy on any cloud. There's a notion of virtual services in Juju so to enable SaaS services. So that means that if you like machine learning made on Azure, but eventually some of your workloads are on Amazon, you may be able to consume that machine learning on Azure from the Amazon cloud very easily. So it's a win-win solution for both of us. So now we're going to do a little hands-on, and I'm going to talk to you about how you should look at your application so that then you can port it in a Juju environment and make it compliant with charms bundles and all those clouds. When I joined Canonical, I looked at different solutions I could build with that, and I focused mainly on big data, and there was not a lot at the time. But I found a blog by Kenny Balu, and he built a solution that was a sentiment analysis based on Storm. And then actually the same solution, he made it also with Storm and Spark. So that's two different things. At the service level, that's very simple, right? You've got something to ingest tweets, then you need to process them, and you need to visualize the results, the output of your analytics. If you break it down a little more and you look at what's in your ingest layer, Kenny chose to use Kafka. So he had a producer, that's something that connects to Twitter and downloads tweets. A broker, so that's a service that's basically a pub-sub mechanism to keep your tweets and allow other services to consume them. And Zookeeper that manages the cluster. Then the processing is what's Storm initially. So there's a Nimbus server is something to manage Storm deployment. Storm workers, so you can have many of those. Zookeeper again to manage that. And Storm by itself doesn't do much. You need to inject additional code into it so that it becomes useful. That's called a topology. The way we do that with Juju is we create something to inject that code, to make it really dynamic. So you can connect your Storm deployment with a GitHub account. And then if you change the GitHub account, you can hook that back to Storm and refresh the topology or re-ingest a new topology to update the code that's running. Then for visualization, Kenny had only a Node.js application, and I wanted that to be a little shinier. So I added a dashing dashboard. That's an open source technology. That's actually my first charm. What does that give in Juju? So on this picture, you can see different units and services deployed with Juju. On here, it's Kafka cluster, where you've got the producer here and the broker there. Then Zookeeper, then you can see Storm. Storm Twitter is my injection of code that connects to GitHub and download code. And then you've got the visualization here. Then Zabbix is a little test we did. It's a monitoring or metrology solution, and we used it to auto-scale the solution. So it could scale out the number of storm workers and scale in if necessary. Now, Kenny didn't stop there, as I mentioned. He also did that with Spark. So usually, if you run a large-scale infrastructure, it may be very complex to switch from Storm to Spark. It implies a lot of things. If you just look at the service layer, actually the only thing you're going to change is the processing of tweets. You want the processing to be Spark, not Storm. But the ingestion just can be the same. And visualization, your users are maybe used to a specific dashboard you have, so you don't want to change that. If you break it down again, well, Spark would run on Yarn, so it's a technology to manage resources. You need compute nodes, you can use HDFS to store your tweets. And again, Spark by itself doesn't do much. You need to inject code in an application to make it run properly. So we've got another code injector that will go on GitHub, download the Spark topology, and install it. And that is the same thing running with Spark. As you can see, same icons, same names, everything is the same here. Now this is not the same, this is the Spark side. Spark Twitter injects code into Spark, and sentiment analysis and dashing are exactly the same. So basically what we did is a drop-in replacement of a big processing unit made of Storm, replace that completely with Spark without changing a line of code in the rest of the system. So I'm going to show it to you now. We've got those two solutions running. And I'm going to start by explaining why it's actually easy to use Juju on Azure. So Ryan before mentioned Easy Juju. So Easy Juju is an image that you spin, and that gives you, when you run it, just a very simple web page. That's the only thing it does is that. When you click on that link here, it downloads your preview file. So you can see it there. The only thing you have to do is upload it. All right. Oh. And wait. It takes about 10 minutes. During those 10 minutes, this machine will consume that settings file, create a Juju environment, bootstrap it, which is create the first unit of Juju that will connect on Azure to add more workloads. When that's going to be done, this page will refresh and add a link to that infrastructure and let you use it. And here is a first version. So just look at the name here. It's Juju in action, number 3. So I did that in the past, just Juju in action, the same thing. And that's the GUI it gave me. If I remove the S here, I can go back to the page I add. Okay, so that's the page you get as a result. And that is the topology that was the Storm version that was deployed. Here you can see Kafka. If I go on the Storm workers, I've got 4 units of that. You can see here all the units. This is a new server, so we can connect on it here. And we can see that Storm is running, its topologies. Then I can also use directly Juju on my machine and connect to Azure. So I can have a command line here, and I've got another environment that runs, and oops, sorry. Okay. So this is my Spark environment, and as you can see, it's exactly the same picture as I had before. Again, if I go on the dashing unit that's here, I can go on the dashboard, and this is my sentiment analysis solution that runs on Spark. And there you can see tweets coming in, and their score here. So those two systems were built through Juju and connected together. You can use the GUI, you can use the command line, and they're both functional and they do exactly the same thing. But half of the infrastructure was actually swapped from one technology to the next in a couple of clicks. So I hope this gives you a good idea of what Juju does and how you can play with it. What I encourage you to do is go on your account on Azure, and then if you go to images here, you can browse VM depot. And if you look at Ubuntu images, you're going to find Easy Juju. You can copy it to your environment. There's a long list of solutions. It's here. So when you add this, it's copying it to your local environment. It's 30 gigs, so it takes a little bit of time. Once it's done, you can then create new virtual machines from your gallery. And in your images, you're going to find Easy Juju just like that. And then you can add. You don't need a lot of resources. You just need a simple A1 instance, and you get Easy Juju. Download your credentials and start playing with Juju. Do you have any questions?
So cool, thanks Sam. So now we have time for Q&A for anything around Juju, Azure questions, things like that. I'll start with one thing. I am more on the application developer side.
Yeah.
So we launched a service, Azure App Service, which includes these things called logic apps and API apps. Amazon has a service called Lambda, right? So where does Juju fit into that landscape?
Right. So first thing, when you have something that runs on one cloud, it runs on this cloud, and you cannot move it to another thing. So I wouldn't say it's lock-in, but it's a bit like that. When you design something with Juju and you've got a charm, this charm should be portable across clouds. So anything you design in Lambda that you can design also in other languages, and then the charm can be made available from Amazon, but also from Azure. So if someone really likes Lambda, they can also create that proxy charm or virtual service that enables Lambda as a charm that can then be deployed in Azure. So on your end, it's going to deploy one unit of service, so it's one VM, but it's going to actually talk to Azure or to Lambda and then enable it, and the other way around. So configuration management was really about one machine that runs. Then those services enable vast scale-out solutions on cloud. And Juju is one layer above. It like unites all those clouds, including private clouds, for developers, so they can have the application anywhere.
So you do on-premises, cross-cloud. Okay.
Cross-cloud is actually not enabled yet, but it's something we're working on.
Excellent. Cool. So we have a microphone if anyone has any additional questions on DevOps, big data, Juju. Any questions at all? All right. Well then, in that case, I encourage you to grab a beer, network. I'd love to understand what anyone is working on currently, or the Canonical guys will be sticking around as well. And thank you.